Day 13 of cracking 500 AI in data science interview questions challenge. 5 questions a day, 100 days. One step closer to your dream job. If you're new here, don't forget to check out the first 12 days in the playlist. You might have missed some key questions that will be important in cracking your interview. Why is data cleaning crucial before modeling? Clean data doesn't just look good, it tells the truth. No matter how powerful your model is, if your input data is full of errors, missing values, or inconsistencies, it will make poor predictions. Data cleaning ensures consistency, no duplicate or conflicting entries, completeness, missing values are handled properly, accuracy, outliers, and incorrect formats are fixed, reliability. Your model is not learning from flawed inputs. For example, in one healthcare project, over 30% of BMI data was missing. We cleaned and imputed it before training, and that alone improved the model's accuracy by 12%. Data cleaning is the invisible engine behind every good model. Without it, even your most advanced algorithm will fail quietly. What are the types of missing data and why do they matter? Missing data is not just blank, it has a story, and you need to understand that story to handle it right. There are three main types of missing data. MCAR, missing completely at random. Data is missing for no reason, like a user skipped a field accidentally. Second type is MAR, missing at random. The missingness depends on another feature. For example, income might be missing more often in younger users. M and AR, missing not at random. The reason the data is missing is related to the value itself, like high income users refusing to disclose salary. Why does this matter? Because it affects how we handle missing values. For MCAR, simple imputation is fine. For MAR, we might use predictive models or group wise imputation. For MNAR, we may need deeper domain insights or flag these rows separately. Understanding this helps you make smarter, context aware imputation choices. How do you detect and handle outliers in real data sets? Outliers are not always mistakes, but they'll mess up your model if ignored. Outliers are extreme values that differ significantly from others. First, I detect them using box plots for visual inspection. Z scores to find points more than 3 standard deviations from the mean. I'll use IQR, interquartile range, to identify values outside 1.5x the range. But detection is only step 1. Handling depends on the context. If it's a data error, I fix or remove it. If it's valid but extreme, I might cap the value by clipping top 1%. Sometimes I even create a new feature like is outlier using underscore in between. Based on my experience, in an e commerce data set, a few users had 1,000 plus orders. They were real wholesale customers. So instead of removing them, we created a bulk buyer flag, which actually improved segmentation. Outliers are not always noise, sometimes they are signals. Just don't let them go unchecked. How do you clean messy categorical variables in pandas? Typos and spaces in categories can silently ruin your model. Fix them before encoding. Let's say we have a column called city in our data set. It contains messy values like New York in different formats. It has unwanted space before in the first one. In second one, we have everything in lower cases. In the third one, we have everything in upper cases. In fourth and fifth one, we do have them in abbreviation. These are all variations of the same city. But if left as is, machine learning models will treat them as different values. So the first step is to standardize casing and remove extra spaces. Using this piece of code, df of city equal to df of city dot string dot strip string dot lower. Instead of string in Python, we are using str. In the first part, look at the left side of equal to df of city. It is used for selecting the column named city, followed by that str.strip, which is used for removing any extra spaces at the beginning or end of the string. For example, before New York we had space, right? For removing that and replacing that as New York without a space. Str.lower, which converts everything to lowercase. So we saw New York in third one, right? Which is completely a uppercase one, which can be converted into lowercase using str.lower. After this line, all your values will be lowercase and trimmed. As a second step, we are placing similar values with a common name, so it would be easy for a machine learning model to understand. Look into this piece of code. Using dot replace, inside dictionary, which got values inside curly braces, we are placing all those values inside a parenthesis. So in dictionary, look into the key New York City, look into the value NYC. The second key New York, the value NYC. The third key NY, the value NYC. So all these keys will be replaced by those values NYC. This is how this piece of code works. It will replace values in the city column using a dictionary. Each key in the dictionary, New York City, NY, gets converted to NYC. So now New York, NY, and New York City all are getting converted into NYC. As an end result, one clean, consistent category, NYC. How to impute missing numeric values using group logic? Instead of guessing globally, ask what do people like this usually look like? Suppose you have a column BMI, body mass index, and some values are missing. You also have gender and age columns. We want to fill the missing BMI values by calculating the average BMI for people with the same age and gender. And using that average, we can fill the blanks. The first step is grouping by gender and age. Then fill missing BMI with group mean. Look into this line of code. df.groupby groups the dataset based on combinations of gender and age. Here we are specifying BMI because we need to focus only on the BMI column within each group. Using dot transform, we are applying transformation that returns a column of same length as the original. Here we are using lambda function for each group so that we can apply the same function to each group. X is the BMI column values in that group. Using dot fill now and dot mean, it fills missing BMI values within the mean of that group. If a female age 30 has missing BMI, it gets filled with the average BMI of all 30-year-old females. Today's pro tip. Before you build, clean. Your model is only as good as the data it sees. Understand your missingness, detect your outliers, and fix messy inputs. The more effort you spend cleaning now, the less debugging you will do later.